From the sidewalk, Millennium Tower looks normal. People still live hundreds of feet above San Francisco. But imagine one thing changes. The tower starts moving. Not enough to fall. Just enough that elevators and plumbing must function inside a building that is slowly leaning. Now, make that personal. You're high above the street. The elevator is your only way down. At the height of the crisis, the top of this tower leaned more than 29 inches off center. And the terrifying question wasn't, how far has it moved? It was, has it stopped? Because if the answer is no, the problem starts climbing the building, leading to the exact question you never want to ask in a skyscraper. What fails first? You do not need to understand geotechnical engineering to understand Millennium Tower. Picture a table. If all four legs slowly sink into a soft floor by exactly the same amount, the table gets lower. But the top can remain level. Now let one leg sink farther. The table rotates. Put a glass of water on top, and suddenly the problem becomes obvious. The water stays level. The table does not. Engineers have a name for this unequal movement: differential settlement. And that difference matters because a skyscraper does not experience movement as one simple number. It can move downward. It can rotate. And a tiny rotation near the bottom becomes easier to see the farther you travel upward. That is how a problem beginning where almost nobody can see it can become visible hundreds of feet above the street. Millennium Tower's settlement and lateral movement were monitored over many years, and peer-reviewed engineering analysis documented multiple periods in which settlement or tilt accelerated and later slowed as ground conditions changed. But even then, leaning alone is not the real nightmare. A building can lean and remain standing. That sounds strange because we instinctively treat leaning and falling as the same story. They are not. Think of a scar on your arm. It may be large. But if it stopped changing years ago, it tells you about the past. Now imagine a hairline crack in a wall. It is much smaller, but every week it gets slightly longer. Which one would you keep checking? That is the key to Millennium Tower. A dramatic historical lean tells you where the building has been. The trend tells you where it may be going. So once the movement became impossible to ignore, the central engineering problem became brutally simple. Not, make the building perfect. Not, erase every inch of tilt. Just, make it stop. That sounds like the beginning of the solution. Instead, it created one of the strangest turns in the entire story. Engineers began a major foundation retrofit in 2021. The objective was straightforward: give the building stronger support, stop the long-term movement. But during the retrofit process, monitoring recorded another period of accelerated movement. Later, engineers writing in the American Society of Civil Engineers journal said the retrofit process itself was the main cause of the accelerated movements being discussed during that phase. The retrofit was eventually completed in August 2023. Think about what that means in ordinary language. The building was moving. They started working underneath it to stop that movement. And while they were doing that, the building moved more. That does not mean the completed repair failed. It means the repair had to be performed on a system that could react while engineers were touching it. Imagine repairing one leg of a fully loaded table while every glass, every plate, and every person remains on top. Except this table is a 58-story reinforced concrete tower. Suddenly the problem feels different. How do you repair the ground beneath a skyscraper when changing what is underneath it can make the building respond again? That is the open loop. To answer it, we have to go below the lobby. Millennium Tower was not built as one giant concrete block sitting directly on bedrock. Its original system used a pile-supported foundation, with the pile tips terminating in dense marine deposits above deeper clay. Below the tower were soil layers capable of changing volume as stresses and groundwater conditions changed. Peer-reviewed analysis linked the tower's settlement to compression and deformation in those foundation soils. It also found that dewatering and excavations around neighboring projects coincided with important changes in settlement and lateral movement over time. But forget the soil names. There is a much easier way to understand the problem. Think of a mattress. Place something heavy on it. The mattress compresses. Now change the pressure underneath one side. The object above responds. Real ground is vastly more complicated than a mattress, but the basic story is familiar. You do not have to touch the roof of a skyscraper to move the roof. Change what supports the bottom. The top has no choice but to respond. And because the building is tall, that response can look much bigger by the time you reach the roof. Take a door. The hinge rotates through a tiny angle. Right beside the hinge, almost nothing seems to move. But watch the handle. It travels much farther. A tall building gives you the same kind of visual amplification. A small rotation near the foundation becomes increasingly obvious the farther upward you travel. That is why a displacement measured at roof level can sound enormous, even though the engineering story begins with changes far below. And this is where the problem stops being an abstract foundation story. Because a skyscraper is not simply a tall object. It is a machine filled with systems that assume the structure surrounding them will remain within a certain geometry. Elevators expect shafts to remain aligned. Drainage expects gravity to keep water flowing along designed slopes. Doors, joints, pipes, and mechanical connections all live inside that geometry. So what happens if the tower continues rotating? You do not need collapse to find out. During the retrofit controversy, engineer Ron Hamburger warned that if the lean reached around 40 inches, systems such as elevators and sewage lines could stop functioning normally. That number was not presented as a collapse threshold, and that distinction changes the entire story. Because it reveals a catastrophe far easier to imagine than an abstract structural calculation. A skyscraper can become a serious problem before it becomes a falling skyscraper. Imagine being high inside the tower. The building is still standing. Your windows are still there. Your furniture is still on the floor. But the elevator you depend on is operating inside a vertical shaft whose geometry is being pushed farther from what it was designed around. Drainage lines still exist, but gravity systems depend on slope. Connections installed in one alignment are being asked to tolerate another. This is the disaster before collapse, not a cinematic explosion. Not a tower suddenly snapping in half. A building that remains physically present, while becoming progressively harder to use as a building. That is where the stakes become personal. The question is no longer, will the skyscraper fall? It becomes, how long could people live normally inside a building that refused to stay where it was put? And if even that is not the final stage, what comes next? The retrofit tried to break that chain by giving Millennium Tower something much easier to visualize: new legs. Imagine a heavy table standing on a soft carpet. You could keep arguing about exactly how much the carpet may compress. Or you could push new legs through it until they reach the hard floor underneath. The real retrofit was vastly more sophisticated, but the logic is similar. Engineers installed 18 new piles to supplement the existing foundation and transfer part of the tower's enormous load down to bedrock, all while the building remained occupied. The purpose was not glamorous. It did not make the tower taller. It did not add another luxury amenity. It was built to achieve perhaps the most boring result imaginable: no more movement. For a moment, that sounds like the end. New support. Bedrock. Problem solved. But before we get there, ask the question engineers never want to answer through experience. What if the movement came back? If the ground beneath one part of the building began moving differently again, the tower would not jump directly to collapse. First, uneven movement would return. Then rotation could grow. The top could shift farther from its stabilized position. Systems that depend on alignment could face increasing difficulty. Deformation would rise. Loads would have to redistribute through a structure being asked to adapt. Damage could become harder to manage. Occupancy could become a serious problem before structural survival became the main question. And only at the extreme end of a severe, sustained, and uncontrolled sequence would major structural failure become a plausible concern. That is what makes this story disturbing. Collapse is not step one. It is the last link. So if Millennium Tower ever started moving again, what would tell you the chain had restarted? The elevators? The pipes? A door that no longer fits? A crack? A sensor no resident ever sees? Or something deeper? Start with the things people use every day. A skyscraper is full of vertical systems. Elevators are the most obvious because the higher you live, the more dependent you become on them. But drainage tells the same story in an even simpler way. Water does not care how expensive the building is. Water follows gravity. A pipe installed with a particular slope depends on that geometry staying within workable limits. The same principle applies to many doors, joints, and mechanical connections. This does not mean every maintenance problem ever reported at Millennium Tower was caused by tilt. That would go beyond the evidence. The larger point is far simpler. A building can become difficult before it becomes dangerous. That is why engineers worry about something called serviceability. But you do not need to remember that word. Just remember the consequence. You do not need a broken column before residents begin paying the price of movement. You only need the building to stop behaving like the stable platform everyone assumed it would be. And if those everyday systems are only the first layer, then the next suspect is the building itself. Imagine a stack of blocks. Change the support underneath one side. The weight does not vanish. The stack has to find a new way to carry it. In a real skyscraper, engineers describe part of this process as load redistribution. But the phrase matters less than the picture. Support changes. The building adapts. Deformation changes. Forces shift. If movement is small and controlled, the structure may remain completely capable of handling those changes. But if movement becomes large, unexpected, or keeps accelerating, the questions become more serious. Where are forces increasing? Which components are deforming? Are connections remaining within acceptable limits? Is the movement slowing? Or is it getting worse? And this is why the most frightening number in Millennium Tower's story was not actually 29 inches. It was not 40 either. The number engineers ultimately wanted was much smaller. 0. 0 additional settlement. 0 additional tilt. 0 new movement. That does not mean magically returning the building to the exact position it occupied when it opened. It means stopping the progression. Think of a doctor treating a wound. The first goal is not to erase the scar. It is to stop the bleeding. Millennium Tower did not need to forget that it had moved. It needed the movement to stop becoming a new event. That distinction matters because people often look at the tower's lean like a countdown. A static historical lean is not a countdown. A changing lean might be. So the important measurement is not simply position. It is direction, speed, trend. Is the line flattening? Or beginning to rise again? That is why monitoring becomes more important after a building surprises you. Not because a sensor can physically hold up a skyscraper, because it can tell you whether the old problem is waking up. And then something happened that should end this entire story. The retrofit worked. By 2025, reporting on the completed perimeter pile project said Millennium Tower had not settled further in the previous 2 years and had recovered nearly 2 inches of tilt. The building was not being reported as marching toward collapse. Monitoring was expected to continue for years. That matters. Because if you hide that fact until the last 10 seconds, you are not creating suspense. You are tricking the viewer. So here is the real reversal. Millennium Tower moved. Its settlement and tilt created years of engineering controversy. A major retrofit was installed. And the movement stopped. That should be the ending. Except it isn't. Because making a skyscraper stop moving once, and proving that it stays stopped, are two different things. Once a building has surprised you, the sentence, "Nothing changed this year," becomes valuable information. And that is where the final part of the story begins. Look at a photograph of Millennium Tower. It tells you where the building is today. Monitoring tells you something much more important: where it is going. That is the difference. If a survey point remains in essentially the same position month after month, year after year, the historic lean increasingly becomes part of the building's past. If that point begins drifting again, the story changes. Long-term engineering study of Millennium Tower tracked settlement, tilt, groundwater, and surrounding ground movement precisely because the pattern over time mattered as much as any single snapshot. The human eye sees a tower. A monitoring trend can see acceleration, or stability, or a change in direction. If movement ever returned, three things would matter very quickly. First, is it accelerating? Second, has its direction changed unexpectedly? Third, is renewed movement appearing alongside increasing problems in the building? One strange measurement may demand investigation. Several worsening signals together would tell a very different story. That is the moment when an old scar stops being history and becomes an active wound again. So what would actually have to happen for a leaning tower to become a genuine structural catastrophe? Start underground. Ground movement resumes. One part of the foundation moves differently from another. The tower rotates farther. Vertical systems lose more of the alignment they were designed around. Deformation increases. The structure redistributes load. Damage becomes harder to manage. At some point, the first major human crisis may still not be collapse. It may be a building that cannot be occupied normally. Elevator restrictions, closed areas, emergency inspections, possibly evacuation if conditions ever became serious enough. Only after a much longer chain of worsening, uncontrolled movement would the conversation move toward major structural failure. That is the point. A skyscraper does not go from slightly tilted to collapsed in one jump. There are warning stages. There are measurements. There are interventions. There are opportunities to break the chain. The catastrophe feels frightening because every step makes intuitive sense. Not because that outcome is inevitable, but because each stage depends on stopping the stage before it from becoming worse. And suddenly, the phrase, "has it stopped?" carries far more weight than any dramatic number. Now look at Millennium Tower again. From across the street, you may see nothing remarkable. People enter. Elevator doors open. Traffic passes. The glass reflects the San Francisco skyline. That normality is what makes this case so unsettling. We expect serious engineering problems to announce themselves visually. A cracked bridge, a broken column, concrete falling into the street, a wall visibly separating. But foundation movement can become important long before a passerby sees anything dramatic. The most consequential part of the story can happen below grade, measured in survey points and trend lines. While the tower above remains expensive, polished, and ordinary, that is what I find unsettling about Millennium Tower. Not that it looks like a building about to fail. It does not. It is that a foundation problem capable of producing years of engineering controversy can remain almost invisible to the person standing across the street, which means appearance gives you very little comfort. The trend is what matters. And this is where money becomes much less impressive than it first appears. Money can pay engineers. It can pay for new piles. It can pay for sensors. It can pay for years of repair. It can pay for monitoring long after the construction crews leave. What it cannot do is make the original movement never have happened. By 2025, reporting showed the engineering stabilization had stopped further sinking, yet the tower still carried a powerful real estate stigma. Many resales continued recording significant losses compared with what owners had originally paid. That reveals another consequence that cannot be measured with a level or a sensor: trust. There are two kinds of stability in a building like this: physical stability and human confidence. Engineers can measure the first. The second is harder. A buyer does not experience a foundation through a computer model. They experience it through one brutally simple question: would I feel safe living there? Once that question becomes attached to a skyscraper, solving the engineering problem does not automatically erase the psychological one. The tower may stop moving before public perception does. Now imagine the sensors tomorrow showed something new. Not a catastrophic jump. Not a dramatic lurch anyone feels in the lobby. Just movement. A little more than expected. Then another measurement confirms it. Then another. The first question would not be, is the tower falling? It would be, why is it moving again? Is the ground changing? Is the new load transfer system behaving as expected? Is the movement local or building wide? Is it slowing? Stable? Accelerating? That is how real engineering danger can arrive. Not as an explosion, as a trend. A line that was flat begins rising. And once that happens, every previous chapter of the tower's history becomes relevant again. The settlement, the tilt, the retrofit, the serviceability warnings, the monitoring. A building can suddenly begin telling a different story, without looking any different from the street. That is the open-loop Millennium Tower can never completely escape. Not, how tilted is it, but, is the line still flat? This is why the famous 29-inch figure was never the real nightmare. A number is easy to put in a headline. A number gives us something to point at, something dramatic to put on a thumbnail. But a building can survive with a historical offset. The far more important question is whether that offset is still changing. Millennium Tower's completed retrofit has been reported as having halted further sinking and recovered some of its historic tilt. That is the good news. But the reason this tower remains such a powerful engineering story is everything that had to happen before engineers could say that. A luxury skyscraper moved more than expected. Its rate and direction of movement changed over time. Nearby underground activity affected the behavior of the ground around it. A repair had to be built beneath an occupied tower. During that process, movement accelerated again. And after all of that, the final definition of success was not glamorous, not perfectly straight, not erased history, just stable. No new chapter, no new acceleration, no movement that starts the chain again. Look at Millennium Tower one last time. Forget the luxury. Forget the property prices. Forget the skyline. Imagine a single vertical line drawn beside it. Then ask the only question that really matters. Is that line staying where it is? Because a skyscraper does not have to fall to become a disaster. It only has to keep moving long enough for everything designed around a stable building to become less certain. The elevators, the pipes, the connections, the structure, the residents, the trust. For now, the completed retrofit appears to have broken that chain. And that is exactly why Millennium Tower is worth remembering. The danger was never that it moved once. The danger was what could happen if it refused to stop.